Hello everyone and welcome to the Terracotta webcast series. This episode, Ditch the Disk, Designing Great In-Memory Architectures. We'll be talking all about the incredible performance gains of in-memory architectures, and we'll also focus on the challenges inherent in in-memory architecture design, along with some of the emerging best practices for addressing those. I'm Andy Raskin, Senior Director of Product Marketing at Terracotta, and I'd like to introduce today's speakers. First, Gagan Mehra, Terracotta's Chief Evangelist. Gagan has had a long career helping enterprises figure out architectural challenges, and he's becoming one of the world's foremost advocates of going in memory. Welcome, Gagan.
Thank you.
And also Orion Latisi. As one of Terracotta's original founders, Orion was among the first to realize the incredible potential of getting data out of slow disks and into fast memory. Thanks. Great to have you with us, Orion.
Thanks, Andy.
Yeah. Before we start, I'll remind everyone that you can always ask questions during Terracotta webcasts. Just type them into the questions panel in your viewing screen, and we'll get to as many as we can at the end. Also, you'll receive a link to the slides and a video of this webcast in the next few days. In this webcast, we'll be talking about, first, why enterprises are starting to ditch their disks. We'll be looking at some of the big challenges in in-memory architecture design, some of the emerging best practices for addressing those. We'll take a look at a great case study, AdJuggler, an ad server platform that is going all in memory and ditching just about all their disks. And we'll talk about, if you want to get started, what's the best way to start an in-memory computing architecture design project. And of course, at the end, we'll take questions. And with that, Gagan, I'll turn it over to you to talk about why folks are starting to ditch their disks.
Thanks, Andy. Thanks, everyone, for joining us today. Let's start with understanding why enterprises are ditching their disks. So we all know that traditionally, the applications have been designed to work with a relational database. What has happened over the last few years that we have seen different types of data gain more importance, which is data through web click-throughs, sensor data, social media data, and a relational format is not the right format to support these different types of data. This data introduces a big data challenge because this is not just high volume data, but it's also high velocity data. To overcome this challenge, the applications need to get re-architected. And this re-architecture introduces more risk in the environment because now applications cannot guarantee performance, they cannot guarantee scalability, there are more frequent outages, and the developers cannot guarantee that introducing a change to these applications will not result in breaking some other functionality. As a result, they have some challenges with maintaining the application performance. The solution is to use in-memory data management technologies that can make the applications perform a lot faster. In-memory technologies help you to maintain large volumes of data in memory, removing your dependency on the database, so you can keep as much as 90% of your data, or even more if required, in memory, keeping only a small percentage in the database. This allows your applications to perform in low milliseconds, basically moving the application performance to ultra-fast, reducing your performance tuning times, making performance testing totally unnecessary. In-memory data management technologies are also cost-efficient because now once you deploy in-memory technologies, you don't need to worry about scalability. You can keep on adding more RAM to your environment, and you should be able to scale to support more terabytes in memory. What has happened over the years, we have seen a drastic reduction in the price of RAM. If you go back 5 years, having laptops with 64 gigs of RAM was not something that was common. And now you have 64 gigs of data available on a mobile device. So that's quite unusual. What we've also seen is an explosion in data. This has resulted in creation of these leading in-memory technologies that can maintain large volumes of data in memory. And that's why enterprises are ditching their disk. They are enabling more data to be kept in memory and making applications run a lot faster. In some cases, run as fast as 100 times faster. The great thing is in-memory doesn't only apply to a single application or a single vertical. We have seen in-memory benefiting almost every vertical out there. To share some examples, in the financial services space, real-time fraud management is benefiting from in-memory technologies. In the government sector, we have streaming data that is being used to fight crimes. In the telecom space, we have customer experience management being handled using in-memory technologies. For media, the customers are seeing a better search experience because now they can search for content a lot faster using in-memory data management. E-commerce sites are running a lot faster because they can buy products a lot more quickly. All the products are maintained in memory. Fraud detection is real time, so customers actually can prevent fraud in real time because they can manage data in memory. Transportation businesses are tracking their fleets in real time, communicating with them in real time using in-memory. Healthcare is improving patient care by managing all patient data in memory. Travel sites also are benefiting from in-memory data management because they allow real-time reservations by maintaining all flight inventory data in memory. So these are some examples of in-memory benefits the different verticals. And the big reason for that is that in-memory has a great business case also behind it. In-memory not only supports your business from a top-line perspective, but also from a bottom-line perspective. Businesses that have adopted in-memory are able to generate more revenue as they can support more customers, more transactions, and more data. They can actually enhance their existing applications to scale and perform better. They can get insights a lot faster than disk and are able to take action on those insights a lot faster, leaving their competition behind. In-memory data management also costs a fraction of the cost of a database, resulting in fewer servers and a smaller operational team to manage those servers, reducing the overall operational costs. It's not just us that are saying these things. We hear similar things from several analysts out there. One example is a recent report from Aberdeen Group that talks about how large companies are using big data. In fact, they say 44% of best-in-class big data performers are already using in-memory data management, and more are planning to deploy it. What we see is none of the laggards out there are using in-memory data management. In-memory data management technologies are deployed in a variety of applications to overcome a specific set of challenges. And to talk about these challenges in more detail, I'll pass it to Orion.
Thanks, Gagan. So, we've been thinking about in-memory technology for a long time, over the years we've identified sort of 6 main challenges to traditional disk-backed architectures that get ever worse as the volume and speed of data grows exponentially. And the biggest one, of course, is always performance. That's where you see it the first. But the big challenge here is achieving not just very, very fast performance, but fast and predictable low latency access to your data.
Well, what does predictable mean in this?
Well, if you can go really, really fast for 90% of the time, but then you're really, really slow for the rest of the time, and you don't know when that slowdown is going to happen, that can have a profound impact on the perceived availability of your application, the perceived speed of your application, and in the case where you have very tight SLAs, it can blow your SLAs.
And what are the things that will tend to kind of wreck predictability?
Well, the biggest one, so network bottlenecks or unpredictable access to web services. But the big one, especially for Java applications, is really a garbage collection. Once you get more than, say, 2 to 4 gigs of data in the Java heap, that's not just in RAM, but actually in the heap. The garbage collection becomes unwieldy to tune. You spend more and more of your time tuning, and it's very brittle. And then after about 8 gigs, the tuning effort becomes almost meaningless. And the garbage collection pauses can go from seconds to minutes, and during which time your application looks like it's just hung and broken. So achieving that predictability is crucial, especially with job applications. So the next one is scale. As data grows exponentially, so your application needs to scale with it. It also one of the that 2 to 4 gig limit with JVMs that I just talked about, that's a real impediment to scale. If you definitely want to be able to scale horizontally and vertically and add servers as you go. But if you have to slice up a terabyte of onboard memory into 2 gigabyte chunks, you're going to be faced with a very difficult management challenge. And it's just, if you could scale up on a single machine that can address a terabyte and have your scaling blocks be very large, that's much more advantageous than the current alternative. So now the third one, reliability. This is related to whenever you move from an old technology to a new technology, you need to bring with it the capabilities that the old technology had in place. The RDBMS, we've gotten very used to its reliability, consistency, all these characteristics that we've grown to rely on. When you move into memory, your in-memory data management solution must maintain all of these capabilities. Reliability is crucial. If you lose any part of your active system, and you will, because that's the nature of data centers, you need to be able to be sure that none of your data is lost, and that you still can run in a high availability configuration.
And this probably affects scale too, right? Because if you're going to replicate data across different servers, if you don't do that efficiently, then you're again faced with a bigger scale problem, right?
Absolutely. We'll get to that when we get to the consistency thing too. So as a companion to reliability, resiliency is also very important. Not just having a system that's highly available, but where you can bring new instances back online very quickly to give you the nimbleness that you need to react to situations and to deploy in a timely manner is going to be key. When you're talking about a couple gigs of data, pulling that into memory can happen really fast. But when you're talking about terabytes to petabytes, you need to have a really fast mechanism for loading that data into memory. So and then we have to talk about consistency a little bit. When you do a scale-out implementation, as most people do, you're going to need to make sure that just like your data was consistent in the RDBMS world, you need to make sure that the data is consistent across your data center. And in the case where you have multiple data centers, you need to be able to keep them consistent across data centers around the world. And then finally, having control, visibility, control, monitoring, and management is crucial. You need to be able to see what's happening to your data, where it lives, where it's going. You need to be able to see all of the nodes in your application, whether they're up, how fast they're going, so that you can take action to triage potential problems that are happening right now, and then also to see the macro trends in your utilization and to be able to take sort of longer term planning action.
Great. Orion, thanks for outlining some of the challenges. Gagan, you've been traveling around the world, meeting with senior architects, CIOs, CTOs who are tackling exactly this problem. What are you seeing as some of the emerging best practices for handling some of the challenges that Orion is talking about?
Okay. So the emerging best practices I'm seeing out there, the biggest one is around performance. Performance is the challenge that impacts almost every application handling large data sets. And most in-memory solutions we see try to overcome the performance challenges in a variety of different ways. But the best practice around performance is to maintain data in the off-heap space within a Java application. This allows your Java application to keep massive amounts of data in memory without impacting the customer experience due to garbage collection pauses.
So this gets to where Orion was talking about. You can literally scale up to whatever, a terabyte on one machine, and and rather than having to split that out among hundreds or thousands of machines.
Yeah, you can scale up or you can scale out, depends on your configuration. Yeah. If you have 32 gigs available on a single machine, you can scale out and have hundreds of nodes in a single cluster to get to your terabytes of data. But the point is that if you have more data in memory, that results in predictable performance compared to your disk I/O. So that's the best practice around performance to overcome this big data challenge. The second emerging best practice is around scalability. The leading in-memory data management solutions use an architecture that's tiered versus a peer-to-peer model to scale the in-memory solution to hit terabytes of data. This architecture not only allows unlimited scale, but it also uses fewer servers, at times as few as 5 times less than the peer-to-peer architectures to enable more data to be kept in memory. Then a big one is around reliability. As you move more and more data into in-memory, you want to make sure the application is reliable. You don't end up losing your data in case of a server crash, just because you're ditching the disk. You don't need to sacrifice reliability. So the best practice around reliability is to maintain a mirror node or a failover node for every active node in your architecture. This mirror node is always kept in sync with the active node. So all the data that's on the active node is also on the mirror node. In case the active node goes down, the mirror node takes over without impacting the end customer. The great thing is that in some cases, if your business wants more failover, you can have multiple mirror nodes for an active node. And that will definitely have some performance impact because you're trying to keep multiple mirror nodes in sync with a single active. But you can have more, higher degrees of failover with multiple mirror nodes also. The next one is around making sure your in-memory solution is able to restart in a short period of time in case, for some reason, your in-memory data management solution crashes.
Or if you do maintenance or something like that.
Yeah, or if you have an unplanned outage or a planned outage. Yeah. That's true. So just because you're recommending keeping terabytes of data in memory, fast restart is a key requirement. And the best practice around fast restart is having an optimized persistent storage that usually is on the file system because the databases are not designed for fast recovery. So building that optimized persistent storage that allows fast reloading in a few minutes versus taking hours or days to reload your terabytes of data back into in-memory. Now, Orion talked about consistency, and we all know that if you have inconsistent data, that can drastically impact how your business performs. The leading in-memory solutions support different flavors of consistency. They allow you to configure different data types to support whether eventual consistency, strong consistency, or transactional consistency. For example, if you have an e-commerce site, your orders could be set up to support strong consistency, just because you want your in-memory solution to be in sync with your database. Whereas if you have, say, online chat customer service on your e-commerce site, that can be set up to support eventual consistency to allow your customers to have better performance.
So you want to allow this configurability based on whatever makes sense for that data set, is that right?
That's absolutely right. And that's what we are seeing with the leading in-memory data management solutions, that they are able to configure depending on the data that you want to hold in memory. And the last one is around control. There is no point in deploying an in-memory solution if you don't have any visibility into how it's performing. So the leading in-memory data management solutions allow you to have a dashboard that exactly shows how your in-memory deployment is performing, how much capacity is still available, what's the transaction rate. And the great thing is it not only shows all that, but it also allows you to integrate with any other monitoring tool out there, using GMX or MBeans, so that your operations team can use a single dashboard or a single monitoring tool to look at all the metrics versus using different tools. These best practices, have been a key reason for the success of in-memory solutions in the market. And I think we'll talk more about it by using one of our success stories.
Yeah, so AdJuggler is an ad server platform that has been using big memory, so Terracotta's in-memory data management solution that is built around, of course, all the best practices we've been talking about to achieve some incredible things. Orion, you want to tell us a little bit about what they're doing?
Sure. So AdJuggler, their next generation ad server is a 1 million transaction per second online advertising marketplace. The ad server is essentially an accounting system, a clearinghouse, if you will, for a huge transaction volume, matching ads to placement opportunities. Now, at this volume, that they deal with terabytes of data per day flowing through the system, plus terabytes of data in RAM representing the audience. So for AdJuggler, speed at this scale is everything. In the words of Ben Lindquist, their VP of Technology, they have scaled past the point where they can use a traditional RDBMS as their business object store. They even need to go beyond moving a database into RAM and go directly to a platform for managing a large number of objects in memory. So they're using big memory as the system of record, and by doing so, that allows their transaction engine to greatly reduce the overhead in reading and writing objects because they don't have to do the object relational mapping. They don't ever have to go to disk for any of the data. And it also, of course, eliminates the garbage collection issues that otherwise would prevent the scaling of a Java application to this kind of scale.
So, Orion, in the slide here, we have this other quote from Ben where he says, "I wanted to throw out the database and with it the disks." But I do see in this diagram there is that one little cylinder there. There is a so what's up with that?
Sure. Well, so of course, moving to in-memory data management doesn't mean you throw away absolutely everything that you've ever done with disks before. You'll still have an RDBMS in your system. It just won't be your data hub like it hasn't been in the past. Moving all of your data into memory gives you all of the benefits, and moving to something that's an in-memory data management system like Big Memory gives you all of the benefits of an RDBMS system plus the speed and scale of an in-memory architecture.
So we're talking about ditching the disks as the place where applications go to get the data they need real fast.
Exactly.
But you still might have some disks around that are doing archival storage, analysis after the fact, things like that. So let's say folks are interested in getting started with in-memory data management. Gagan, what are some of the ways what are some of the things they should think about in starting a first project?
Yeah, so the best way I've seen to get started is to identify a low-risk, high-return opportunity that is potentially a quick win. Because a quick win is the fastest way to get more believers and increase the adoption rate within your organization. It is important, though, to share your plans with the senior executives within your organization and get their support, because these executives are the ones who will be the disk champions within your organization and make sure different groups understand how successful your in-memory data management deployment is being. The project also should have clear metrics so that you can share, how successful your project is being with the different groups within the organization and make everyone aware of your project's progress.
What are some of the good metrics that you've seen folks use for some of these early projects?
The biggest one I've seen is around performance. Once you start using in-memory data management technologies and ditch the disk, you will see a drastic improvement in performance. As I mentioned earlier, sometimes as much as 100 times faster. So once you start sharing those metrics with the different groups within the organization, I guess everybody will get excited about using in-memory technologies. And lastly, I would say, if you have any questions or challenges with your projects, we are always here to support you and answer any questions around your challenges. With that, I think.
Yeah, with that, we're ready for answering some questions. I'll remind the audience that anyone can ask a question. Just type it into the Q&A window on your screen. We're already getting a bunch of them. If we don't get to your question, you can email us later, and I'll give you some information about that. But let's take some of the first ones. So first question comes in, isn't in-memory data management just really a big cache? Why can't I treat it like a big cache?
Well, as we talked about, caches are great, and you can use big memory or any, if you can use an in-memory data management as a cache, they do a lot to speed up applications, and almost every application has one. But caches treat data as essentially disposable. You pull it into memory. Whether it's the result of a calculation or it's the local representation of data that lives in a system of record elsewhere. You can really treat that data as disposable, throw it away, and then reload it with no effect on your business or on your data. But the more you use data in memory, the more that data becomes valuable, and you need to stop thinking about your data in memory as just disposable cache data, and really start treating it as first-class system of record data. And that's sort of what we mean by thinking about it as in-memory data management rather than just caching.
Next question: how does this fit with Hadoop, with something like SAP HANA, other places where information is being stored? Gagan?
Yeah, so in-memory technologies, especially the ones that we are talking about here, is about making big data big, fast data. Hadoop's not known for big, fast data. Hadoop's known for processing data in a batch mode. And what we actually have done is we have built connectors here at Terracotta that make the Hadoop jobs run a lot faster. So you can read directly from in-memory or write directly to in-memory. So not only are you making your Hadoop jobs run a lot faster, but you're also making your downstream applications read from memory, so they run a lot faster to get to the insights. HANA is another in-memory product, not really a product that's used for Java applications, more suitable for SAP deployment that we have seen. Also, it's still a database. All HANA is doing is replacing a relational database with another database that's in memory. What we are proposing here is making your applications a lot faster by storing data directly in an object format.
And a critical component of that architecture is using the local RAM on your application server machine, because that access to that data is orders of magnitude faster than what you can get over the network, no matter where that data lives, on disk or in memory on a remote server.
Our next question: how does the data get saved if you have to power the system down? So does it get stored on a disk somewhere? And the questioner says, I'm referring to basically the data that would otherwise be stored in say, an Oracle database.
So what we have is a homegrown store that's part of the in-memory solution. So in case...
So you're talking about Big Memory now.
We're talking about Big Memory, our flagship product for in-memory data management. So in case of a power outage, the data is stored on disk in our proprietary file system. And when the power comes back up, the server comes back up, we are able to read that data from disk and load the in-memory solution again with all the data. So you don't have to...
It's a file system that's specifically designed for fast restart. Unlike, it's basically engineered for in-memory architectures.
And when we say disk, we're also talking about potentially SSDs.
Sure.
So flash storage, which I believe Big Memory is tuned specifically to work with flash storage as well. So again, we're not talking about completely removing disks from the data center, but it's more about using them in a place that's more about a backup, reliability, archival way. Yeah?
Exactly.
Okay. How is Big Memory different from Coherence, Gemfire, which was recently talked about in the new Pivotal initiative? How is it different?
So from an architecture perspective, Coherence, Gemfire use a peer-to-peer architecture model compared to Big Memory, which has a tiered architecture. And as we shared earlier, for scalability, a tiered architecture works a lot better. That allows you to scale 2 terabytes of data. Also, we have seen, comparing Big Memory to Coherence and Gemfire, that for similar size deployments, we end up using a lot fewer servers, sometimes as few as 5 times less than these other products.
Great. Well, thank you, Gagan and Orion, and thank you to our audience for some really great questions. If we didn't have time to get to your question, or if you'd like to follow up, please feel free to email Gagan at the address here. We'd love to hear how your in-memory projects are going and about your challenges and successes. You can also post to the Big Memory Forum, which you can find at terracotta.org, or just tweet out with the hashtag Big Memory. In case you missed portions of this webcast, the recording of the entire event will be available at terracotta.org very shortly, and we'll send out an email when it's up. Thank you, and we look forward to having you join us for future episodes in the Terracotta webcast series.